Welcome back. This is the second part of Lesson 3, Unit 1. In the first part, we learned about limits and continuity. We had the continuity test. We had discontinuity. We had the jump discontinuity, the infinite discontinuity, and the removable discontinuity. In this lesson, we're going to be learning about end behavior. End behavior, if you recall from Algebra 2, was what's happening at the ends of some function. So you might recall that in this case we had a function and we would look at the ends. And we had a very specific way in which we wrote the answer. So if I wanted the end behavior of this function, we would put it as x goes toward negative infinity. Looking at the graph, we can see that f of x is going to go toward negative infinity as well. Furthermore, we also had that we had to look at the other end. As x goes toward infinity, f of x also goes toward negative infinity. And we can see that if I pulled up, I can see that if we look at this graph here, we can see that it keeps going down in that direction. So as x gets smaller and smaller, f of x is going down, 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 down. Same thing on this side. As x gets larger and larger, f of x, or the function, is going to continue to go down. Now, in Algebra 2, we were able to write it like this, and this is how I taught you guys how to write it. Now, we're going to start looking at it from a different point of view. We're going to look at it from this FST point of view and with limits. So, we're now going to start writing end behavior with limit notation, saying the limit of this function as x goes toward negative infinity is going to be negative infinity. And the other one, the limit of this function as x goes toward positive infinity equals negative infinity. This is now how you're going to start writing your end behaviors. This is the baby way. We don't write in babies anymore. We're in FST, we're in grown-up math, and this is how we're going to start writing it. Now, there's other graphs. If we examine this function, we're going to do the end behavior of this function. When I look at this function, it looks to be as x goes out further and further, f of x looks to be growing in the positive direction. And as x goes more negative, it looks like the function is going more negative itself. But we need to be able to look at this graph deeper. So I'm going to zoom out of this graph, and we're going to see that as x goes out toward infinity, wow, as it goes out toward infinity, it looks like it's coming back down to the 0. And the same thing on the other side. As x goes toward negative infinity, the graph, or the function, is going toward 0. So if we're going to write that, we're going to put the limit of this function, and this is that function that was up there, the limit of the function as x goes toward negative infinity is going to be 0. And the limit of this function as x goes toward infinity is also going to be 0. This is the end behavior of certain graphs that go toward a number rather than infinity or negative infinity. These are typically going to be functions that have rational expressions in them. The last thing we're going to talk about today are these vocabulary words. The vocabulary words: continuous function, limit, discontinuous function, infinite discontinuity, jump discontinuity, removable discontinuity, non-removable discontinuity, and end behavior. All of these you will be able to figure out the definition to in the 2 videos. Hopefully this video will be able to help you finish your notes, and you should be ready to do your homework on Monday.